provide primary power supply for a satellite, there are two possible sources are used. They are nuclear supplies and solar supplies. Nuclear primary power systems. These systems are used where the solar energy is weak, such as deep space missions. There are two categories of nuclear power supplies as given below. Type 1 and Type 2. Type 1 is nuclear reactor type and Type 2 is thermoelectric generator type. In Type 1, there will be a boiler with a working fluid like mercury. This boiler will be heated by a small nuclear reactor and vapor is generated. This vapor will be used to drive a turbine alternator combination in a Brayton cycle. Brayton cycle is nothing but a thermodynamic cycle which will be working by applying the constant pressure to produce heat and electricity. This system can also be referred as a miniature steam generating station. In Type 2, this is a commonly used type for smaller power supplies. It has a single radioisotope thermoelectric generator which is shortly known as RTG. This RTG heats lead telluride thermocouples and hence electricity can be generated. Advantages. If nuclear supplies are used, there is no need for batteries during eclipse. Eclipse is the scenario where the spacecraft or satellite will be hidden from the sunlight from reaching it. Okay, so the spacecraft will be hidden by the earth, moon or some other celestial body and it prevents the sunlight from reaching it. It is called an eclipse. So in those scenarios, nuclear supplies can be used. And for missions where solar energy is weak, nuclear supplies can be used. And drawbacks. The spacecraft electronics should be prevented from radiation damage. Okay, and the little shielding for curium 244 and plutonium will be more expensive. And cheap and easily available nuclear fuels are difficult to handle and dangerous too. They cause environmental hazards also. For example, strontium 90. Solar cells can also produce power. Large number of solar cells should be arranged in series parallel connection, which is called the solar panels. See, this is the block diagram of a solar system. See the components involved in it. Estimation of total power requirement should include these four. Transmitter of power of all the transmitters, receiver power, housekeeping power, battery service during eclipse. And we are going to see few equations. Let's see one by one. Total transmitter power, P suffix T. So this is the formula, this is the equation and the field values are explained. And total transponder power. So it includes transmitter power and receiver power. So housekeeping power. During eclipse, housekeeping power also includes the eclipse heater power, that is P suffix He. So the final equation will turn into PH is equal to PHO and HPT plus PHE. So this is battery power P suffix E and total battery energy is given by U is equal to PETE by D. And battery capacity is given by this formula and charging power is given by this formula P suffix C. Total primary power capital P is equal to K into total transponder power plus housekeeping power plus capacity, power capacity. K is the design margin factor and this is the parameters required for solar array. Solar flux density is given by this formula and power generated by a single solar cell is given by this formula. So total number of cells in the array is given by capital N. Therefore, the solar array required is given by capital A. and using this formula. Thank you.